Yeah, it started recording.
It started?
Yeah.
Okay, go. So this is EE533 lab 4 recording, and we will have a brief discussion about the system we built, like the instruction detector system. Okay, so we have three teammates. I'm Haobo Yang and
Hey, hi, I'm Rohith here.
Hi, I'm Yukun Li.
okay. So let me start it. So we have already built our whole system in the Windows XP, the net FPGA tools, and now we extract all the .v files into the Fedora system. Here we use the make to do the bit file to download to our net FPGA. So let me first show our structure. So inside the lab4, and this lab4 folder is copied from the reference router. And let me show the structure. So here is all lab4 file, and our all source file is inside the source. Okay, so the job FIFO, you can see the job FIFO was merge, compare, so on and so forth. And we have a top level like the user data path. So here we have defined all the structure, all the modules we have built, and here is the alias. The alias module is defined when we use the alias inserted in between the modules. And we have also built a pass-through modules to test if the whole system is functioning while after we like insert a blank log into it. And if we want to do some modification to do a path through one, we need to change this IDS module's name to path through. Like uh, yeah, like this. So uh so let me show the path through. Okay, so inside the path through, we didn't do any more modification. We just to remove the parts we don't need, and we connect all the input to the output so that it's going to be like uh, a very blank system. So no other function in it. Okay. So after we having all this file, we do the make. We cannot do the make in the source file, so we go to the okay, there's another thing I have to mention about that. Like we should copy after we copy the whole reference projects into our Fedora system. We need to also copy the net the net file of the IP core we generated in the in the XP system, and also the include files into it so that we can do the synthesis work. So we will go to the synthesis folder, go into it, and do the make clean to clear the last version of the making file trash and do the make operations. So if we have the IDS, we change the user data path as I mentioned, and if we want to do the IDS, we keep the user data path so that after we can make the synthesis file work. And after that, we will get the BAT file. So it will take a lot of time. So I don't do the real make file here, but I can show you the BAT files later. And after we do this part, we can get the registers that be distribute to us with related byte file. So it will be generated inside the lab in the lib. Yeah, in the lib. Inside the C. Uh, okay. Okay. So it's inside the register define lab4.h. Okay. So you can see it. The IDI's part pattern high register has been assigned to 200. The low is 204. The CMD is 208, and the met register is 20C. And we need to change the IDS register, the .xc file. We read it, and so that's this IDS register will have the target register. We can do the software operation to directly change the not FPGA's registers. So we already modified it inside our IDS register file. You can see it here. So the two register address are matched. Okay, so okay, so I think that's all the like Bedfield part I represent, and then let the Rohit do take the.
Hi everyone, I'm Rohit. So I'll show you. As of now, we have shown you like how to generate the bit files, and how to make the necessary changes to generate the bit files. So let me load the bit files into the NetFPGA and see how we can communicate between the nodes. So we have like we have moved all the bit files to the net FPGA, and this is a bit file for the pass through, and this is for the bit file with the IDS intelligent detection system. So let me first load the pass through bit file. So this is now I'm loading the net FPGA with pass through bit file. Yeah, as you can see, it's been loaded, and now I'm running RKD. So once I have this. Now let me try to communicate between the two nodes using ping. So this is my node 0 terminal. So let me try to connect to node 3 and 3. As you can see, it's been connected. And similarly, I'll connect to node 0. Yeah, as you can see, this shows that both node 1, we were able to like transfer data between node 0 and node 3. Yeah, and further, let's try to test the performance between these two nodes. And for that, we are using this iprep command. And here, node 3 is ask like acting like a client, a server, and node 0 is acting like a client. Yeah, as you can see, this is the report. So we got an average speed of 127 megabits per second, and I'll kill this. Okay. Uh, so next, let's load the bit file of IDS pass-through. So this is the bit file of IDS pass-through, which has all the detect, drop FIFO, all the modules that we need to detect the malicious packet. Uh, so let me run this. Yeah, now we have loaded the IDS bit file and running RKT. And let me configure the, and for this to work, we need to configure the registers. So to configure the registers, we are using this IDS reg reg script. So first, let me reset, and next I will set the pattern as, so this is my match pattern A B C D E F G, and as you can see, the high low are also being set. And let me before we run anything, let's look at the matches register. So as you can see, the value of the register matches is 0 when we do the reset. And now similarly, let me ping from node 3 to node 2. So as you can see, we were able to send uh, data between node 0 and node 3. And similarly, let's check the performance between node 0 and node 3. Yeah. So I'll kill and to check whether our intrusion detection system is working or not, we need to send packets containing the pattern. So only then we'll be able to know whether our IDS is dropping the packets that that's that contains the pattern. So for that, let me for that I'm making this node 3 as my server, and from node 0 I'll be sending the packets which contain the pattern ABCDEFG, which we loaded into our comparison register. So first I'll load this pattern to a uh, file. I have it. Yeah, as you can see, this file pattern abcdefg.txt already has this uh, pattern. And from the client, I'll be I'll try to send the uh, this text file. So in this command, ipref, instead of sending random packets, now it will send this file. Yeah, as you can see, it has sent one datagram, but it did not receive any acknowledgement. That means this packet is being dropped by our IDS system. And now let's check uh, whether our matches register is updated or not. So as you can see, if you look at the matches register, its value is being incremented to B. As you can see here, the ipref had made like 10 attempts to send, and each time it tried to send, the packet is being dropped. So and whenever it's dropped, so the matches register is incremented. So as you can see, since we have tried to send it 10 times, so the matches register is incremented by 10 here. Yeah. Now let's try to send a random packet which does not contain the file. So now I'll be sending this file pattern.txt. As you can see, we were able to send successfully. Send one datagram, and you can see uh, the bandwidth value signed here, and you can see the server also received and also sent an acknowledgement. And now let's see whether the register matches is incremented or not. So as you can see here, the value remains same. That means there's no the packet that went through IDS did not contain any uh, pattern. And now will take over, and he will show you the scripts to show the performances and or how to uh, measure the performance between each different nodes and in different configurations and different protocols like UDP, TCP.
Okay, I'm sharing my
I'm sharing my screens. Okay. Now, wait, I'm sharing my screens, and first we're doing our screens of step 5, that is TCP performance variance. It's okay. We just okay. This is our FPGA. We are sending command into this 5 terminal, and we could show how they update it. Oh, wait. Let me check. Wait a minute. Okay, I'll change the port. Since the port is already used, we are changing it to some other random. So
Yeah.
okay, now I'm showing my code. Let's go. This is for the step 5 scripts that testing the connections of TCP mode between each node. Like we could send that firstly, it connect to itself, that, and because they are the same port, so the transfer may be very large. But like each node will connect to each other, and you could see that now these two nodes connect to each other, and then these two nodes connect to each other. Yeah, so you could see that the normal transfer is about 100 megabytes, and the bandwidth is about like it's around 100 MB per second for the TCP mode. Yeah, and now this node began to connect to each other. It's just a reference. We don't want to show the whole structure, the whole process. So I'll close it for the next scripts. And since it runs all the scripts, it will create a log file on your desktop, and you could watch all the data show in this 4 terminal. So I will close it, and we continue to next scripts. So we'll stop for sending commands to these 5 terminals, and now we are going to the step 6. Step 6. First we are going to test the. Let me check it. I think firstly we are going to test the UDP mode. UDP mode of NIC, right? Okay, we could test the UDP performance in NIC. Like in this time, these 5 nodes connected to each other one by one. Like they are sending about 1 G bandwidth. And it lasts 30 seconds, so we have to wait 30 seconds. Now we could see that it's in the NIC for the NIC bit file, it's about 19 lost, and the bandwidth is around 10 to 20, around 10 to 20. So it's relatively slow. And we need to wait for, okay, it's already queued, and now we're going to try our router, our reference router bit file. I think this is the command. Oh, it's the wrong command. Let me check about it. It's the router. It's the okay. I lose an R. Sorry for that. Okay, now we are testing the same strings, but we change the bit file to router reference, and we'll wait 30 seconds to see what's its performance, and we could indicate that the bandwidth will grow. Yeah, the bandwidth, like for the NIC reference code, the bandwidth is around 10 to 20, but now for our routers, the bandwidth grows to very large, and the jobs is less. This means the router bit file would have a better performance because it's about hardware. And now we could test our step 7. It's about sending codes by our IDS. By our IDS in UDP and TCP mode. First, we'll test it in our UDP mode. Yeah, now like each client, like each node has create one server and 3 clients to the other 3 nodes, and they are sending an UDP connections for others. And one of them is sending the right pattern, but others are sending random patterns. So we could know that each nodes have 2 connections. It's 3 and 4, or 3 and 4. Like each nodes have 2 connections, but one loss because they are the match patterns. So they drop. They don't send to the server. So we could only find two port connections in each node. But we could find three sending commands on each node. Like this is the matches pattern, and this is the random pattern we select. So it means we work. And if you like, you could walk the log file creating here. And now we're testing the TCP mode. TCP mode will receive 3 connections, but only 2 connections sending the data. Like we make it. Okay, we could. Yeah, firstly, the node 1 will send a TCP client for node 2, and you will find connected in node 2, but no data because it's the right pattern. But if we send in the random pattern, you will send there is a transfer, and there's a transfer because it's not a matches. And then now it is sending, and you will find there's a pattern. There's a transfer here, but when it sends the pattern here, you will find there's a connect in TCP mode, but no data. Yeah, it's the same. It's the same for rest. I don't show you the whole string structures, but it verifies that our IDP bit file works very well. Okay, that's all.
Okay, so that's the whole system representations here, and thank you for watching.